Here, I want to talk about the fundamental or the basic limits where f of x is uh, unbounded. Okay? Alright? Hello? Frank? Okay. First of all, before we may have talked about this, where the limit as x approaches 0 of 1 over x, that's the basic limit that we're going to be looking at. This actually, if we look at our graph, this does not exist. It strictly does not exist. You can't even say it goes towards negative or positive infinity because it's a two-sided limit. So if we were to look at this and see our function as we approach the x value of 0 from the right side, we go to positive infinity. If we approach the x value of 0 from the left side, it goes to negative infinity. So here, this does not exist. So that's the first thing. Because it's a two-sided limit, you evaluate it from the left and from the right, and they have to agree for the actual limit to exist. So instead of looking at the two-sided limits, let's look at the one-sided limits as x approaches 0 from the right side of 1 over x. Now, if x is getting closer and closer to 0, but all of the values that it's getting closer, all of the values that are used to get closer to 0 are positive numbers. That means from the right of 0 is positive. Then we have a positive divided by a positive. Maybe I'll put a little plus sign. This is positive, so positive over positive is a positive. So here, if the denominator gets super, super tiny, the entire fraction gets super, super large, and we'll say that it approaches positive infinity. This actually still does not exist, but we denote it by positive infinity. It's going towards being unbounded in the positive direction. Okay. It's conversely, I don't know. On the other hand, we have x approaching 0 from the negative side, the left side. Anything smaller than 0 is negative. So we have 1 over x. Now, if we think about this, this is a positive divided by a negative. So that means we get a negative number, and in this case, since the x is getting super, super small, the entire fraction is getting super, super large, except for we're going there from the negative side. And thus we have negative infinity, which is not a number. It's still unbounded, but those are the two fundamental, or the basic limits where f of x approaches infinity. Here's the thing. Not only, like, you have to check from the left and right. That's what throws people off. Anytime your x is approaching 0, or anytime some piece in your function is approaching 0, you got to check from the left and right, because you could approach 0 from the positive standpoint or from the negative standpoint. So that's what I'm going to write down right now. Oh, I wasn't. I thought I hit record, and then this. I'm not. I didn't. I didn't. I didn't. Yeah. Okay. So if x is approaching 0, or some piece of your function is approaching 0, then be sure to check each one-sided limit. Then I'm gonna have an example for that. So your first thought in this is like, oh, plug in 6, and what do you get? Well, if you plug in 6, you get 3 in the top. Oh, that's nice. That's nice. That's not a 3. It's just a 3. It's just a 3. And then you probably get 0, and you go, oh, that's gonna be infinity. And you'll be like, that's the answer. And then I'll say, no, settle down. Remember, this is going to 0, and I just said anytime you have either x approaching 0 or some piece of your function. This is some piece of my function approaching 0, then check the two-sided limit. So this actually may or may not be the case. So I'm going to cross it out for right now. I got to check the two-sided limit, so I'm going to do that right now. So here, in the top, yes, we do get 3. In the bottom, we're approaching 6 from the left side, which means we're plugging in things like 5.999, something smaller than 6. All right, here, so something smaller than 6, minus 6, that's going to be a negative number. That's going to be negative. It is going to 0, but it's going there from the negative side. So we have the whole entire fraction going to infinity. However, we're going from the negative side, so we have negative infinity here. Oh, that's a little bit different. Very nice, very nice. What if I have the limit as x goes to 6 from the positive side? Sorry, I mean from the right side. Well, we should see. Again, this goes to 0. This goes to 3. But in the denominator, we're plugging in things like 6.01 or 6.1 or something like that, something that's bigger than 6. So then this is going to be positive. Positive divided by a positive is the positive. If the bottom is going to 0 and the top is not, the whole thing goes to infinity, as says our basic limit there. So this limit actually does not exist because these don't agree. Well, first of all, they're infinity. So the limit doesn't technically exist, but we can't even describe the two-sided limit at all because the one-sided limits don't agree. So the two-sided limit does not exist. In much the same way as this didn't exist, and we had this and this. So you got to be careful. This green note here, that's the important part. Good day. I said good day.